What I like talking about pizza, it's on my mind a lot. And I know we're supposed to be talking about heat. But now, if you're impatient like me, you probably put a slice of pizza on a plate as soon as it comes out of the oven. And you probably noticed the bottom of the plate warms up. So let's think about what's going on here. We have the temperature of the pizza. We have the temperature of the plate. The temperature of the pizza is quite a bit higher when we put it on the plate than the plate itself. So the plate starts to warm up. So the pizza's temperature, on the other hand, starts to lower. It gets cooler. So this will happen anytime one object is has a temperature that is different than another object, and it always flows from warm to cold. The temperature, what is it? Well, temperature is actually the measure of kinetic energy in any objects, right? And so kinetic energy is the energy of movement. So how fast are the particles or the atoms, molecules moving? So when the pizza is warm, its particles are moving fast than when it's cooler, faster than when it's cooler. And for the plate, those particles are moving a little bit slower on average. So what's happening when we have heat transfer? What's happening when we have a hot object touching a cold object? Well, this is called heat. So heat is the super important word. Heat is the transfer of energy between objects with different temperatures. And as you can see with our plates and pizza, heat is transferring from the hot pizza to the cold plate. So from the hot object to the cold object. Well, so always from hot to cold, always. But why is that? Why is it? Let's go ahead and break down our problem and really dig into what's happening everything in the system. So in real life, a lot of energy is also going to be transferred from the pizza into the air around it. But for this problem, we're going to simplify and just look at the pizza and the plate. So we can kind of model the plate here with a higher temperature with particles. So we draw particles as little circles. And each of these circles is in motion, has kinetic energy. So we can draw that or represent that with arrows. So the longer the arrow, the more kinetic energy it has. And so they're moving and vibrating. And then the pizza, they're moving and vibrating a lot because it's hot. And we're going to use yellow to represent these particles. I'm going to assume the particles in the pizza and the plate have the same mass. That's going to simplify this as well. So now if we focus on the movement of these particles, the pizza particles are moving faster and further apart because they are hotter. They have more kinetic energy. When you put the slice of pizza on the plate, the particles at the surface of the object will come into contact with the plate and those particles in the plate. And as those particles in the pizza collide with the particles in the plate, they transfer some energy. So if you look at one particle from the pizza with its longer arrow because it has more kinetic energy, and it collides with the particle from the plate, it's going to transfer some of its kinetic energy into the particle from the plate. So this is why water objects always transfer to objects. And so now the particle in the plate has more kinetic energy or a higher temperature, and the particle in the pizza has less kinetic energy or cooler temperature. So it's going to slow down while the particle in the plate is going to speed up just a little. Well, if we take this and that particle in the pizza is going to hit other particles in the pizza further back and going to transfer energy from that hotter particle to the cooler one, and kinetic energy will transfer. And this will just keep happening. Particles will keep hitting particles over and over and over again until all the particles in the system have, on average, an equal amount of kinetic energy. And when all of these particles have an equal amount of kinetic energy, we say that it is come to equal thermal equilibrium. Thermal equilibrium. What is thermal equilibrium? Well, thermal equilibrium is just a term we use when no heat is being transferred anymore because all the temperatures are. So in other words, all those particles have, on average, the same kinetic energy. No kinetic energy is being transferred from a warmer object to a cooler object.